Alright, welcome to our series of videos for the summer assignment, the math review for AP Physics 1. So we're going to start off here with scientific notation today. I'm going to go through each part of the summer assignment besides the calculator practice because that is fairly straightforward. Go through similar examples to what is on the summer assignment. So if you don't have an understanding or you forgot these math skills, you can get a quick refresher through these videos. Again, the whole idea of this summer assignment is to just show that you're willing to do the work to be in the class. There's nothing that's going to be this long as far as homework goes during the school year. This is just a quick refresher of things you've seen before. Also, with this math, AP Physics 1, as far as the test goes, math is not necessarily the most important thing. It's just being able to actually explain what is happening in a situation with math that will help that. So if your skills aren't there at the moment, we're going to get you there and you will be fine. So let's move into the overview of scientific notation. Yes, there is actually an equation for scientific notation. You probably have either never seen it before or you just really never thought about it after seeing it the first time. But there is an actual way about going to make a number into scientific notation. So this is a way to make numbers more palatable or just more easy to talk about, essentially. So if you have a really small decimal, especially when we get into some of the Regents topics, towards the end of the year, you might end up with really small numbers. So you're always going to convert these things into scientific notation. So say if you have like 0.00001, you're not going to say that. You're going to make it then in the scientific notation 1.0 times 10 to the negative whatever. So it's easier to talk about with everybody else instead of saying all the decimals, all the numerals after a decimal or something like that. So the equation here, you just have m times 10 to the nth power. So m is a number between 1 and 10. So again, you're going to end up having, say, 0.01. You then make that into 1.0 times 10 to the negative second or something like that. So it's always going to be between 1 and 10. You're not going to have like 100 times 10 to the whatever. That's not proper scientific notation. You're going to see, again, Regents topics, not really an AP idea. There is actually one scientific notation on the Regents reference table that doesn't follow this rule, but we'll talk about it when we get to that point. Don't worry about it right now. And you have an integral, which is a whole number exponent. So again, it has to be a whole number. It's not going to be a decimal exponent. For numbers that are 1 and greater, so not a number below 1, not just a decimal, and the exponent is going to be equal to counting the numbers before the decimal, or numerals before the decimal, minus 1. So I'm going to show this in the examples. So say like 100, 100 would be 3 numbers. So let me write it down actually here. So say if you had 100 here, there's always going to be a decimal after the last 0, so you'd have 3 numerals before that decimal ends up coming up, and then this would end up being 1 times 10 to the second in scientific notation. Again, because you have 3 numbers before the decimal, and then you just subtract 1 and end up with 1 times 10 to the second. For a number less than 1, n is just equal to counting to the first non-zero numeral. So again, with this example that I talked about earlier, this is 0.01. If I count to the first non-zero numeral from the decimal, I go 0, that's 1, and I go 2 here. So I'm going to end up with, again, you're going to have between 1 and 10, so 1.0 times 10 to the negative second. With this as well, you can always check it with your calculator. So if you have a TI-84, if you go to mode at the very top, you can see here at the very top of mode, you have 3 different modes. So you have normal, science, and engineering. If you click over to science, you can check any of these. So you can plug back in 100 into the calculator, and you can see that is 1e, which is times 10 to the second power, or the same thing for 0.01. If I plug that into the calculator, I can see that that is the proper answer. If you have a scientific calculator, the one I recommend for that is the TI-30XS. It is $15. It has like the same multi-view function of a graphing calculator. Same idea, you go to mode, it's the second line this time, go to science, and you do the same exact thing. So if I plug in 0.01, this time it actually gives it to me as 1 times 10 to the negative second, because there is no E function on the TI-30XS. So that may be a little bit easier to read for you. So I'll put that in the Google Classroom as well if anybody does not have a calculator and wants to have one, but we'll also have them in the classroom for use throughout the year. So let's move into the examples here. All right, moving into the first two examples here. My first example is going to be 25,300. So I can see right away that this is a number that is 1 or greater. So I can use the rules for that. So remember, the rule for 1 or greater is going to end up being that I'm going to count all the numerals before the decimal, and the decimal here would be after the 300, after the last 0 there. I'm going to count all the numerals before that decimal and then subtract 1. So starting off here, I have 25,300. So that's going to end up being 2.53 times 10 raised to the. So let's count our numerals here. So I have 1, 2, 3, 4, 5. So I have 5 numerals before the decimal. So subtract 1. So I'm going to have 2.53 times 10 to the 4th. Let's make that 2 a little bit nicer there. All right, so my second example here, and you can check that in your calculator as a just in case if you want to be 100% sure of that, if you're not as confident in scientific notation. Your second example here is 0.0003. So this is going to follow the rules for less than 1 for scientific notation. So that means I'm going to count the first non-zero numeral. That is going to be my exponent, and the exponent then will be negative. So again, we're going to start off here with my decimal, so that's 3.0 times 10 raised to the. So you have here 0.0, so that's 1, 2, 3, and then 4. So it's 4 to my first non-zero numeral. So I'm going to have here negative 4. So that should be 3.0 times 10 to the negative 4th. And again, you can check that in your calculator. So let's move into our last two examples. All right, moving into our last two examples real quick. I have here number 3, 450. So this is a number, again, that is greater than 1. So we're going to follow those rules, counting the numerals before the decimal, which the decimal would be after my 0 here, and then subtracting 1. So we have here 450. That's going to become 4.5 times 10 to the, and before my decimal I have 1, 2, 3. So that means that I'm going to then subtract 1. So my exponent is going to be 2. So I'm going to have 4.5 times 10 to the second. Again, you can check that in your calculator as well. My last example here for scientific notation is going to be 0.006. This number is less than 1, so we're going to follow the rules for less than 1. That means we're going to count to the first non-zero numeral, and that is going to be my exponent, and my exponent is going to be negative. So I have here, this will turn into 6.0. times 10 raised to the, we have here 1, 2, 3. So that means I'm going to have a negative exponent of -3. And again, you can check that in your calculator to make sure you have the correct answer. All right, so I hope this walkthrough scientific notation was helpful. Um, Good luck on the rest of the summer assignment, and I will continue posting these videos throughout the week.